Hey guys, this is going to be a video for the 2.6 homework. And in this section, we've covered a little bit more about quadratics. We've kind of focused more on setting the vertex, and we've also introduced the idea of what's called the axis of symmetry. We've also talked about how you can graph how a quadratic can be presented in multiple forms. So there is vertex form, as on this first page. There is standard form, as on the second and third page. And on the last page, it's intercept form. As for this first page right here, I'll probably just do, I'm just going to do example 3. And let you guys do the rest of those, mainly because in 2.5 we also 2.5 was graphing with an emphasis on vertex form, and so we've already learned how to graph all of these right here from 2.5, and so you should be pretty good and set to work on these ones. So I'm going to jump on 3, just kind of give you an idea if you've already forgotten or anything like that, and let you go with that. So, like I've always said in class, that whenever you're graphing a quadratic, the first thing you do is plot the vertex. So the vertex is that very center point, I guess, of the quadratic. And then after you know where that is, you use the 1, 3, 5 rule. And so I know that this this quadratic is being shifted to the right 2. So right 2, and then it's being shifted up 4. So that would place it right here, the vertex. Now we're going to use the 1, 3, 5 rule, but just one thing to note is that because this constant out here is negative, that causes a reflection over the x-axis. So it's been reflected over first of all, and then it's made these shifts over here. So this will be facing upside down. And instead of the 1, 3, 5 rule, we're going to be using a rule that's being multiplied by a factor of 4. And so this is going to be the 4, 12, 20 rule, I guess you can say. And so I guess before we do that, we can put the vertex. So the vertex is going to be at the coordinate point 2, 4. Okay, and then the axis of symmetry is going to be about the line x equals 2. And so that's where the axis of symmetry is. Make sure you state it as x equals 2. That's where the axis of symmetry is at. Okay, and now let's use the 1, 3, 5 rule. So we're going to go over 1 in both directions, and then we're going to go down 4. So that would be right here and right here. And then we're going to go over 1, and then we're going to go down 12. So that would put it right here and right here. Okay, and then should be good to draw it right there. Okay, and that's how you're going to do the rest of these ones. So example 4, example 1, example 2. Example 1 and 2 don't have any vertical shifting happening here, so it's just a horizontal shift. And yeah, there you go. Now let's get into standard form. So standard form is a little bit more difficult because it's just not as straightforward. Vertex form is literally just giving you the vertex, and remember that that's your first step in graphing a quadratic. And so vertex form, it's much easier to graph because the vertex is just right there given to you. Standard form requires a little bit more work. So to find the axis would be the first thing that you're going to want to do in these problems. And I guess before we get going, a standard form is whenever you have an equation, y equals ax squared plus bx plus c. This is standard form. So each term is written in descending order of the degree. So this term has x of degree 2, this term has x of degree 1, this term doesn't have an x, okay? And so that's a standard form. That's how you know it's in standard form. So x squared, x1, 3 terms written in standard form. So first thing we're going to do is find the axis, and that will help us find where the vertex is. There's a formula for the axis. X is equal to negative b divided by 2 times by a. And b is going to be the number or the coefficient of the middle term, so the term with just an x, and a is going to be the value of the number in the leading term, x squared. Okay? So in this case, our axis is going to be equal to negative 2. So I'm looking up here and I'm looking for the value b. So 2 is going to be that term, negative b divided by 2 times by the value of a. A is going to be the coefficient of the leading term. And if it's just x squared, there's no other number here, like say like in this one where it's negative 4, or this one where it's 0.5, then the value of a is just 1, so times by 1. So this will just be negative 2 divided by 2, which will come out to be negative 1. So my axis of symmetry is at x equals negative 1. So if it helps, you can draw that in here. So at the vertical line, x equals negative 1, that right there is our axis of symmetry. And then to find the vertex, well, we've already found the x-coordinate. So the x-coordinate of our vertex will be the same as our axis of symmetry. Because I know that if this is where the graph is symmetrical, like in this one right here, if that's where the graph is going to be symmetrical about, then the vertex has to be on this line. So the vertex has to be on the x-coordinate of negative 1. Now we just need to see how far up or how far down it's going to go. And how you find that is by plugging negative 1 into the x spots and then evaluating the function at that. So we'll say y is equal to, and I like to use my parentheses, so negative 1 squared plus 2 times by negative 1 plus 1. So notice I'm just copying down this equation right here, but in place of x, I'm using negative 1. And then let's evaluate. So this will be equal to 1 minus 2 plus 1. So that's 1. This comes out to be minus 2. And then this will just be 1. And so this becomes 1 plus 1, which is 2. And then minus 2. So this comes out to be 0. So my y-coordinate is going to be 0, and this right here is where my vertex is going to be. Now, you can use the 1, 3, 5 rule and graph the rest. And since the value of a is 1, the 1, 3, 5 rule remains as 1, 3, 5. There's no vertical stretch. So 1, we're going to go over 1 and up 3. And then you'd go over 1 and up 5, which would put it somewhere like right here. And then you can graph the rest. And there you go. Okay, let's try 6. This one might be a little bit different. Got a kind of a different number in the front, but still the same process. So we're going to use x is equal to negative b divided by 2a. So negative b is going to be 8 divided by 2 times by a, which is negative 4. A is negative 4. So this will be equal to negative 8 divided by negative 8, which will just be positive 1. So my axis of symmetry is at x equals 1. So I'm going to go ahead and just draw that in here. Again, it's not required that you draw the axis of symmetry, but maybe some find it useful. And then if I'm going to find the y-coordinate, I'm going to plug this value into the function. So we have negative 4, 1 squared plus 8 times by 1 plus 2. And then evaluate. So this is just going to be negative 4. Plus 8 plus 2. So if you think about it, this right here is 10 minus 4. So this comes out to be positive 6. And that's going to be the y-coordinate of my vertex. And of course the x-coordinate is 1. So there's my vertex. I can plot that right here. So we have 1, 6. Note that the y-axis is counting by 2's. Let's go ahead and figure out our 1, 3, 5 rule. So our 1, 3, and 5 rule is being multiplied by a factor of 4. That is our stretch. So we're going to apply that to these right here. And so we're going to have 4, 12, and we'll call that good because 20 is going to be probably too far for us to plot. But also note that the leading term is negative, which means it's going to be going down and not up. Okay, so over 1 and down 4, so that would put it right there. And then over 1 and down 12. So this will be 2, 4, 6, 8, 10, 12. Let me make sure I count that right. So 2, 4, 6, 8, 10, 12. Yep. So all the way down at the bottom. Oops, I think that one should be right there. Okay, and there you go. Very, very skinny graph. Okay. Now let's look at 7. 7 is a little bit weird because, well, we don't have a middle term. We don't have the middle term that includes the x, but it's still technically in standard form. However, this is actually a little bit easier to graph because I don't really have to do the equation. You can think about this right here. This is actually kind of like as if it were in vertex form, like up here, where we don't have a shift left or right. Okay, but you can treat this as either form. You can just say like this right here. So how about you just say, well, x is equal to negative b divided by 2a, right? Well, if we don't have a middle term where b is included, that just means the value of b is 0, because 0 times by x would be 0, so this term wouldn't even be here, thus leaving me with just those the first and the last term. So then that just means that the axis is going to be at 0. This is going to be at the axis of 0. So anytime you don't have a middle term, the axis of symmetry is going to be at 0, which means it can only move up or down, which again, that just means that this right here is a vertical shift down 1. You just have to read it like it was in vertex form. So my vertex is just going to be at the point 0, comma, negative 1. No middle term. So that means the x-coordinate is 0. And I just have to look at this to see that it's going down 1. And then it's negative here, so it's going to be going downwards. And the value here isn't anything like 1 or 1/2, so we can just use the 1, 3, 5 rule as usual. So 1, and then 3, and then if we had room, we'd go 5, but that should be good right there. And there you go. You have your graph. All right, let's try 8. 8, we do have a middle term. Let's go ahead and use, find the axis. X is going to be equal to negative 1. So we do have a middle term. The middle term x has a coefficient of 1. If it were 0, then there wouldn't be anything here like this one right here. So even though you don't see it, you're not just going to put b as 0. It doesn't mean that b is 0. If it's not there, it's 1, because we still have this x here. This is 1x, not 0x. 0x would look like this right here where there is no x. Okay, so negative b divided by 2 times by a. A is 0.5. I'm going to write that as a fraction though, 1/2. Okay, So this is going to be negative 1 divided by, I wrote it as 1/2 because it's easier for me to see 2 times by 1/2. Those are multiplicative inverses, which means when you multiply them together, they're just 1. So this will just be negative 1. So the axis of symmetry is x equals negative 1. The x value of our vertex is going to be negative 1. Now we're going to plug this into the function to find out what the y value is. So f of negative 1 is going to be equal to, again, I'm going to write it as a fraction. I just like writing those as fractions instead. Negative 1 squared plus negative 1 minus 3. Okay? Negative 1 squared is 1. And if I multiply that by 1/2, it's going to be 1/2. Plus a negative 1 will just be minus 1, then minus 3. Okay, this right here is going to be minus 4. So we have 1/2 minus 4. So I guess you can think about that as equal to negative 3.5. Because you have negative 4 plus 1/2. So negative 3.5. If you're writing it as a fraction, though, that is negative 7/2. Okay? So you can put that value here. I don't care if you put it as a fraction or as a decimal. I guess in this case, I'll put it as a decimal, negative 3.5, even though I prefer fractions. Okay? So our axis of symmetry is at negative 1. We're going to be down 3.5, so that would be right here. And then we're going to use the 1-3-5 rule, but this time we're multiplying by 1/2. So this would be 1/2. This would be 3/2, or 1.5. This is equal to 0.5. And then this would be 5/2, or 2.5. Okay, so we are going to go over 1 and up 0.5. So over 1 and 0.5 up. And then we're going to go over 1 and up 1.5. And then we're going to go over 1 and up 2.5. 1, 2, so I think that would be right there. 1, 2.5. If you wanted to keep the pattern going, it would just be 3.5, then 4.5, and so on and so forth. Alright, and there you go. Okay, looks like we're not really doing any graphing on 9, 10, 11, and 12. I know, right? Hallelujah, right? So instead what we're going to be doing is finding the minimum or maximum value of the function, describe the domain and range, where the function is increasing and decreasing. So, just to kind of give an example of how you can figure out that information. So the minimum value refers to the minimum y value or maximum y value. So this right here is a y value. So in this case right here, this function has a maximum. You can see that it has a highest y value, and the maximum would just be whatever the y value is of your vertex, so negative 1. The minimum in this one would be whatever the y value is of your vertex, negative 3.5. The minimum here would be 0. The maximum here would be 6. So going back down here, how do I find the minimum maximum of this one? Well, we just need to find the vertex, and then we can go from there. So this is in standard form, you can say, but again, this one doesn't have a middle term, right? So no middle term, which means just like this one, if you it has a 0, if you were to use this formula, b would be 0, and 0 divided by anything is still 0. The axis is at x equals 0. So the vertex would be 0, comma. Now I need to find the y. Well, two things you can do. You can plug this in, and look, if I plug 0 in right here, it just becomes negative 1. But then you can also look at it in the way of, well, there's no middle term, then the last term is just a shift down 1. So then the vertex will just be at 0, negative 1. And how do I know if it's a min or a maximum? Well, this is positive, which means it faces upwards, like this one right here, which means we must have a minimum value. So we have a minimum value, and the minimum is equal to -1. Okay? The domain. Well, for quadratics, at any time we've graphed a quadratic, remember the domain is asking for the x values of the function. What are the x values of the function? So there's an x value of this function at -2. It also has an x value at -1. It has an x value at 0. It will have an x value at -10 because this keeps going down and to the left. This will keep going down and to the right. And since it keeps going right, and since it keeps going left, this function will have all x values in it. And so we'll just say all real numbers. That's the case for all quadratics. So this is a quadratic. Domain is all real numbers. This is a quadratic. Domain is all real numbers. This is a quadratic. Domain is all real numbers. Okay, now the range. So the range is not going to be all real numbers for a quadratic, but we do know the minimum value. So like right here, the minimum value of this function was -3.5. And if that's the minimum, then it will take on all y values. It will have the y values of this function will be everything greater than that. For this one, this is the maximum. So all y values of this function are going to be less than -1. The y values of this function are going to be all values greater than 0. The y values of this function are going to be all values less than 6. So it all just depends on if it's a minimum or a maximum. So the range here will be y is going to be greater than or equal to -1. This is the minimum y value, so the y values of this function are going to include this and everything greater than it. Okay? Now, where is the function increasing and decreasing? So let's take this example. So going left to right, the function here, going left to right, is if you like take your pencil and move it down, this is going in a downward motion if you move left to right. So this is decreasing here. It changes at the vertex, and then it goes to increasing. Okay, so you're going to base increasing and decreasing off of the x value, not the y value. A lot of students mess that up. A lot of students base it off of the y value. No, you're going to base it off of the x value. So some students will say, well, you're decreasing up until 0, but that's the y value. No, you're decreasing up until, because you're reading left to right, that's how you're going to describe where you're increasing and decreasing. You're decreasing as you read from left to right. You're decreasing until x equals -1, then you're increasing. Here, whenever the graph is upside down, you're increasing going left to right up until the vertex, which is x equals 1, then you're decreasing. Okay, so here's our vertex. The x value is 0, and we're facing upwards. Okay, so this graph has the vertex 0, -1, right? So we are decreasing until x equals 0. So I'm going to say decreasing when x is less than 0, but then we're increasing when x is greater than 0. When x is greater than 0. There you go. Okay. Let's see. I think you guys should be able to do these ones. Okay. Find the vertex, because all of these values are based off of the vertex. Most of them, well, actually, so this one, so the minimum maximum is the y value, based off of the y value. We already talked about how the domain is all real numbers. Okay, so this is based off of the y value. Range is based off of the y value. Increasing and decreasing are going to be based off of the x value of the vertex. So find the vertex by 1, x equals -b over 2a. Then 2, plug it in. And that's going to give you the y value. So then you can determine the min or max depending on if it's facing up or down. You can find the range, again, based off of the y value and if it's facing up or down. increasing or decreasing. It depends on if it's facing up or if it's facing down, but you're using the x value. So, but I will go over question 12 because this looks a little bit different than what we've seen before. But we're not going to really treat it any different, okay? So we're still just going to go over the same old routine. So we're going to use x is equal to, notice that we don't have a c value, the constant value. But the good thing about our function, or about our equation, negative b over 2a, is that it doesn't use that last value. So this will still be equal to negative b, which is negative 12, divided by 2 times by a, which is 2. So this will be positive 12 over 4, which will be equal to 3. So my vertex will be 3, comma. Now I need to plug this into the function. So we'll do h of 3. Plug in 3 for x. That will be 2 times by 3 squared minus 12 times by 3. So it's going to be 2 times by 9 minus 36, right? Okay. And that's going to be 18 minus 36, which will be equal to negative 18. So the y value, negative 18. This graph right here faces up because the first term is positive. So it faces up, goes like this. The vertex right here is going to be to the right 3 and down 18 units. Okay? The max or the min. So is this going to have a max or a min? Like we said, it faces up. So this is a minimum value. What is the minimum value? It's the y value, so negative 18. What is the range? Well, since it's facing up, all y values of the function have to be greater than that. So y has to be greater than or equal to negative 18. When is it increasing? So it's increasing when you're reading left to right, to the right of x equals 3. So that's when x is greater than 3. When is it decreasing? When x is less than 3. And there you go. All right, so that should help you. Hopefully you can finish those other two that are there. And let's wrap up these last couple questions. So the graph of the function, graph the function and label the x-intercepts, the vertex, and the axis of symmetry. These are in the form, these are intercept form quadratics, okay? Now they're quadratics because if you were to multiply these out using the FOIL method, look how you'd multiply x and x, so you'd get x squared. So could you FOIL this out, put it into standard form, and graph it like you would standard form? Sure. Is that what you're going to do? Nah, because it would take too much time. That's more math that you need to do, and there's a process involved to help you graph these right here without having to do that. So the x-intercepts, you know what I'm going to do? I'm probably going to do 14. Oh, man. I'll probably do 14 and 15. A lot of people will have questions on 15, I'm sure. So, in any case, if I take a look at these factors right here, the factors will tell me where the x-intercepts are. So take the factors x plus 2 and x plus 6 and set them equal to 0. So why are we doing that? Because we're looking for the x-intercepts, and if these are the factors, if I set them equal to 0, well, x-intercepts have a y value of 0. So like if the x-intercept were here, this has a y value of 0, x value negative 4. This has a y value of negative 2. X equals negative 2, y value of 0. Sorry. And so on and so forth. And so we're trying to find what y equals. Well, we're trying to find what x equals when y is equal to 0. So I'm going to explain this using the zero product property. So if I make this equal 0, because that's what I want it to be, I want to find the x-intercept, so I want y to be equal to 0. So I set that to be 0. Well, the only way to get 0, so let's say I have 0 is equal to a times by b. Well, this is a product, and how do I get 0 when I multiply two things together? One of them has to be 0. So either A is 0 or B is 0. So that's what we're saying here. If I make this equal to 0, well, 3 isn't going to be 0. 3 is always 3. But this x plus 2 and this x plus 6 would have to be 0, correct? Because these are all being multiplied. This is being multiplied by these two values. This is also being multiplied by these two values. So you can think about it like this. This x plus 2 represents the A. This x plus 6 represents the B. And since their product is 0, then either this has to be 0, or this has to be 0, or both have to be 0. And so that's how I find my x-intercept. And then I just solve these equations. So if I subtract the 2 to the other side and subtract the 6 to the other side, well then I get x is equal to -2, and here I get x is equal to -6. And there are our x-intercepts. So at x equals -2, at x equals -6, that's where this graph right here has has x-intercepts. Okay? Has x-intercepts. Now if you want to graph them as coordinate points, that would be -6, 0, and -2, 0. Sometimes students just like to write x equals -6 and x equals -2. For this chapter, I think I'll be fine with either or. Okay, now let's jump to, we're not going to quite do vertex here, jump to the axis, because notice here, for any of these graphs right here that have x-intercepts, so this has x-intercepts and this has x-intercepts, the axis of symmetry is equidistant from the x-intercept. Because this is an axis of symmetry, that means the x-axis has to be equidistant, or the x-intercepts have to be equidistant, the same distance from it. So if that's the case right here, the axis of symmetry has to be right directly in the middle of these values right here. So this has a space of 1, 2, 3, 4. So therefore, the axis of symmetry has to be at this line right here. It has to be at -4. So the axis of symmetry has to be x equals -4. So kind of just as a side note, the reason why it'd be better to use something like this right here is because x-intercepts are more accurately described with points as opposed to vertical lines. Vertical lines are better described with equations right here, like this right here. So x-intercepts, if you write them like this, this kind of looks like it looks more like a line, because x equals -6 is anywhere right here. X equals -2 would be anywhere right here. So that's why it's better to write points, but that's but yeah, anyways. Okay, so our axis is going to be at -4. Well, since I know where the x value is, right? Because the vertex is going to be at the x value of -4. The vertex is the x value of the vertex is always going to be where the axis is. So the vertex has to be somewhere on this line. How do I find where the y is? We're going to do the same thing like we did whenever we were graphing in standard form. We're just going to plug this value into the x spots here. So I'm going to do that over here. Y will be equal to 3, and then x is going to be -4 plus 2, and then x is also going to be -4, plus 6. And evaluate. Make sure you do your order of operations. So inside the parentheses come first. -4 plus 2 is -2. -4 plus 6 is +2. Then you just multiply these three numbers together. So 3 times by -4, and that's going to become -12. And that's going to be the y value of your vertex, -12. So -4, -12, that's where our vertex is. The value outside here is positive, so you know it's facing up. Also, if the vertex is down here and your x-intercepts are up here, then it has to go up, right? So also, you already know where 2 points are. If you use the 1-3-5 rule, which is fine, this right here is going to be multiplied by a factor of 3. So 3 is the leading number out here. So that's going to be our stretch factor. So now it's going to be 3, and it's going to be 9, and it's going to be 15. Now watch this right here. So I'm going to go over 1, and I'm going to go up 3, right? So 1, 2, 3, over 1 and up 3. If I go over 1 again, I'm going to go up 9. So this right here is -9, and if I go up 9, we'll be at the x-axis. And look, that's where our x-intercepts are at, which we already have those points graphed right there. So we have everything we need to graph that. And there you go. Okay? So as you do number 13, you can do these x-intercepts, okay? You can find the vertex, or sorry, you can find the axis. It will be in the middle of them. Plug that value in here, do the math, and get the y value. You'll have your vertex. The coefficient out here is just 1, so the 135 rule will just be 135, and yeah. Okay. All right, for this one right here, so the only thing that students really get tripped up on is that, okay, well, I'm going to find my x-intercepts, right? So going back up here is you take the factors and you set them equal to 0. So here's my factor, x plus 6. So x plus 6, we're going to set it equal to 0, right? And we're going to get x equals -6. So I have an x-intercept at -6, 0. So that's going to be right here. Okay, well, where's my other factor? The only other thing I see here is x, which is weird because that's what they're usually looking like. If you have a factor of just x, this is easy. Take the factor, set it equal to 0. Oh, well, it's already 0, right? That's going to be your other x-intercept. So if you see a factor of just x, the x-intercept is 0. So that right there is where the other x-intercept is. So the other x-intercept is at the origin, 0, 0. Okay? All right. I'll let you guys finish this one. I'll get you head in the right direction, though. Find the axis. The axis is going to be directly in the middle of these 2 points, right? Okay. Find the vertex by plugging that value back in here for x, right? So you're going to have negative some value wherever the middle value is, right? Multiplied by that value plus 6, right? I don't know what that value is. I'm just putting a dot here to represent that, okay? And then you can find your vertex, okay? Also, think about this right here. The vertex, so the graph will be facing down because it's negative. So you should know that the y value of the vertex has to be positive because our x-intercepts are here and it has to be facing downward. So it's got to be somewhere above, not below, okay? All right. Okay, I think that's going to be it for me, guys. Hopefully that you guys find this helpful. If not, just make sure to ask questions at the beginning of class.